Hello and welcome to the Daily Space for today, January 11th, 2019. I am your host, Dr. Pamela Gay, and I am here to put science in your brains. It's going to finally be a slow news day. This has been a wild week for science news, coming at us fast and furious, all from one direction, and that direction was from Seattle, Washington, where we had the 233rd meeting of the American Astronomical Society. Well, as that meeting winds down to a close, we have no more press conferences. We have all the news has come out. And so what's left is a little bit of planetary science coming from a completely different corner. And this time it is science that is going to be coming to us from Japan. So in today's top news story, I have new information on observations taken of Venus. And I personally find these observations particularly pleasing because they show how different kinds of wavelengths. Thank you so much, Guido, for the subscription. This shows how different kinds of light can be used to look at different parts of a planetary atmosphere. In this case, the JAXA mission Akatsuki, which has an IR telescope on it, has been observing the atmosphere of Venus orbit after orbit for several years. Over time, it has built up observations of the topmost layers, but also with the infrared light, they're able to peer through those top thick layers of atmosphere that ultraviolet and visible light can't get through, and see down to the warm layers beneath. These clouds, they're finding, have particular weather patterns that repeat day after day. And when I say day, for Venus, I'm talking 240 some odd Earth days. This is a very slowly rotating world. Its rotation is actually opposite the majority of the worlds in its solar system, or put a different way, its North Pole is where the rest of us point south. This odd, flipped upside down, slowly rotating world also has a runaway greenhouse effect. This means at some point in its past, the gases, the waters on its surface got superheated. And as they altered its atmosphere, the heat just kept building up and building up. In this particular case, what we see happening is Venus, once upon a time, may have had a liquid ocean, but due to other effects, the strong carbon dioxide, carbon monoxide constituency in its early atmosphere, visible light, ultraviolet light, higher energies, shorter wavelengths of light would pass through the atmosphere. And then they'd heat up the soils, and the infrared light would radiate away from the surface. But the clouds would block that light from leaving the planet. The effect would be that that ultraviolet light just kept, not ultraviolet, that infrared light just kept bouncing around inside the atmosphere, building up the temperature, building up the temperature. Today, there is no water on the surface of Venus. Mercury may have frozen ice in some of its craters, not so much Venus. It is hundreds of degrees in temperature. This is a world that rains acid, and it's one that we have only been able to observe the surface of in radar. We've only been able to observe the surface of its clouds looking in optical and ultraviolet. Now, looking deeper with the infrared camera, what they're finding is the atmosphere has long-lasting cloud patterns, not too different from our own jet stream. And these long-lasting cloud patterns show circulations where a band of temperature will dip down from the northern or southern latitudes towards the equator. And these circulating patterns, well, they circulate the heat, and they also are long-term in their duration. So it's not like our atmosphere where the pattern seems to be changing from year to year, from El Niño to El Niño. Instead, it's this long-standing tilted wave pattern, and it's just kind of cool. Or really hot, depending on how you want to use those two words. Anyways, Venus, it's awesome. Check it out and know that what we see on the surface is in no way a reflection of what goes on beneath. Now, as yet another reminder, next weekend, Sunday night going into Martin Luther King Monday, if you're here in the United States, or just Monday as they call it everywhere else in the world, there is going to be a lunar eclipse that will be visible in the Americas. This is the kind of thing where it doesn't matter what hemisphere you're on, the moon is still out there shining, or in this case, slowly not shining as it passes into the Earth's shadow. This is the kind of event where you can get all your non-astronomy friends outside looking up, freezing if you're someplace cold like I am, and get them to be awe-inspired and maybe start wanting to join you in your hobby. Lunar eclipses aren't that rare. They generally occur at least once a year, sometimes twice. You can't always see them where you are, but they're out there taking place somewhere. Now, the reason we don't have them every single month is the moon's orbit is tilted relative to the sun. So if we have our turtle Earth and our Tasmanian moon, sometimes it's going to be passing up, passing down when it's relative to you, who I will call our sun. But sometimes it's up, crosses in front. That's when we get a solar eclipse, passes down, and passes behind, causing that lunar eclipse. There was a partial solar eclipse just a couple weeks ago, and now as we move from new moon to full, we get to see the lunar eclipse that so often, or pretty much always, accompanies those solar eclipses. So start planning ahead, folks. Start inviting people over for a week from Sunday. Things will start around 9:40 East Coast time. That's 6:40 out in the Pacific. And plan to be up late. The entire event will take several hours. Full totality will occur at 11:40 p.m. Eastern. So invite everyone over to look at the moon. Now, that's all I've got. I think everyone is still recovering from the American Astronomical Society meeting, and I am okay with that. I don't know about you, but all of my brain cells are currently full of new concepts that they're still working to distill out. So if you've got any questions, go ahead and throw them into the chat. As always, please remember to @me, CosmoQuestX. That helps me find your questions a little bit faster. Now, while you type those questions in, I just want to remind all of you, CosmoQuest is a production of the Planetary Science Institute working in collaboration with Youngstown University. We are here because of you. Give us a follow. They're free. Find out every time we go live. Miss an episode? That's okay. Everything gets posted same day, generally, same day over on YouTube on our CosmoQuest X channel. If you're watching on YouTube, hey, we record live over on Twitch, most Mondays through Fridays at 1 p.m. Eastern, 10 a.m. Pacific. That's 6 p.m. London time. Now, we are, as I said, entirely supported by you. We are sustained by your subscriptions on Twitch. We are supported by your Patreon contributions at patreon.com/CosmoQuestX. And really, every single bit really matters. So thank you for all that you do, all that you give that allows us to keep making the science go. And we're going to do everything we can to make you proud. Thank you, Trekker Kev. Thank you so much for the bits. Thank you. You guys are awesome. Thank you for your compliment, the X-King's Guard, or X the King's Guard. Thank you all. Now, I'm going to scroll and see if there's any questions. There will be, I see Larry is reminding everyone, we will be recording Astronomy Cast live over on YouTube. Thank you, Veronica Cure. Thank you. We will be recording Astronomy Cast Live over on YouTube later today at 3 p.m. Eastern, noon Pacific. That is 8 p.m. London. Check it out. We are going to be talking about nucleosynthesis in the cores of stars and starting to get at what is it that makes, well, a brown dwarf or brown dwarf, or red dwarf or red dwarf, and all the rest of the stars appear wherever it is they appear on the main sequence, or rather on the color magnitude diagram. There will be a lot more coffee drink before we record Astronomy Cast. So looking to see if there's any questions out there. Will it also appear here? No, Mike Cassidy. CosmoQuest, Astronomy Cast, Star Strider, Universe Today, we are all affiliated channels. But until I know how to auto-host a YouTube channel, we can't show it here. Currently, all of our subscribers are over on YouTube, so we're just going to leave things the way they are. Sorry for the dog barking in the background. Okay. Yes, Eddie's opinions are spoken. It's true. It's true. Any other questions that I might be able to answer? We are still continuing to work on updating the CosmoQuest.org website. I will be working on that when I am not prepping for Astronomy Cast later today. There will be, once I eradicate all the stuff that needs to be eradicated, I will probably be live streaming over on Star Strider or here, depending on what I'm working on, the creation of the new pages. So as I've said before, we're in the process of we have to update all of our legalese and things like that now that we've switched institutes and switched funding. But once I've eradicated all the things that need to be eradicated, we're rebuilding something new and beautiful and wonderful thanks to your funding. And I'm going to do it with your input wherever I can. So Paranor, it turns out that Stella's vet visit had to be moved because the vet had something come up. So it's supposed to be tonight, but we're supposed to be having a massive storm, and I'm getting all of these "do not leave your house" warnings. So I'm going to call the vet after I'm done streaming and find out what the vet wants us to do. So it may be that Monday ends up being vaccination day for the puppy. So I see that Astro B London is adding Pamela. Well, I am Pamela, but CosmoQuest X will get it highlighted. It's okay, I see it anyways. If you were the edge of our universe and looked up in the sky, what would you see? So that's one of those things that's super weird to think about. So if you're on the surface of a balloon and you can only look around in 2 dimensions, looking up is the equivalent of looking out across the surface of the balloon in all directions. And no matter where you are on that surface, there is no edge. No matter where you are on that surface, if you can't perceive anything not on that surface, there's no center, there's no out. Well, we live in a three-dimensional reality that is on the surface of a 4-dimensional hypertoroid, which is a fancy word for 4-dimensional donut. Don't try and conceptualize a 4-dimensional donut. Human brains weren't meant to do that. But the reason we know it's donut shaped is, and I don't have a donut. This will work. Okay, so we're going to pretend this is a donut for a moment. This is a group of seed pods that I got in Hawaii. So a donut is the one shape where you can have 2 lines that race around in parallel on the top. You can have 2 lines that race through the center. You can in fact have 2 lines going in any direction along the surface, and they will always stay parallel. This is the one surface, well, not these seed pods, but the 4-dimensional hypertoroid is the one surface that allows those parallel lines to stay parallel. Now, as that donut expands, those lines are still going to stay parallel-ish. I mean, it depends on if they're gravitationally bound, if they're getting carried away by the expansion of the universe, all those kinds of things. But nonetheless, we are on the surface of a 4-dimensional hypertoroid, and to us, there is no edge to perceive. And in fact, if we have a finite universe, we know that we only perceive a few % of that finite universe, because as we look out at the cosmic microwave background, we don't see the same pattern of light coming from two different directions. We don't see those parallel lines that have had time to come at us in two different directions around the surface of that donut. So the thing is, there is no edge. It's a continuous surface in more dimensions than we can think about. And now I really wish I lived someplace with a Dunkin' Donuts, because as a Boston kid, those are the only donuts that are legit. But next weekend, I will be in Boston. So any of you who are in Boston, I'm going to be attending the Aresia Science Fiction Convention at the Boston Park Plaza. Come check it out. So, donuts. I will be in Boston and I will get donuts. Hannes Vorwerp is asking, would the presentation about watching the violence of planet formation be able to be done with all sky data or just using a satellite to look at a single system? So yesterday, I think it was yesterday, there was a presentation about a solar system that had been observed, and they saw the distinct signatures of individual impact situations occurring in that young solar system. This specific kind of observation really requires long-term monitoring of a single system. You can do that all sky if you have the right dedicated facilities that are sensitive enough and willing to give all their telescope time to monitor this system, monitor that system, monitor this system, using nearby systems such as those that are being discovered by TESS. Now the issue is, we don't have that system. We don't have that telescope. So for now, we find the best, easiest to observe, most likely to give us data candidates. Observe the bejesus out of them. You know what Matt Whatley said, Mark Whatley, we science the out of them. And we get the information and we build up the case to someday, if we need it, have that all-sky telescope to observe extrasolar planets or not. We just need to figure out what is most necessary. And this is something that our entire community does together. We know we have very limited resources. So we gather on a regular basis and do our decadal surveys. And working with the National Academies of Science, we as a community put forward recommendations on, for the next 10 years, this is how our funding should be spent, so that we can answer the most important questions that technology finally allows us to answer. So I don't know what the future is going to hold, but the potential is there to have that dedicated extrasolar system observing survey science instrument. But for now, it's one telescope or many telescopes, each taking their turn to look at this system and that system as they're proposed by observers. Okay, looking to see what other questions are out there. So Trekker Kev, I agree, 25 centimeters of snow is not that much. As someone from Boston, I'm like, anything under like 80 centimeters, we're good. And I have a Jeep Wrangler, so I particularly feel that way. Now, the thing is, people here don't know how to drive in snow. They tend to like have they have cars that aren't front wheel drive. And I'm not worried about the snow. I'm worried about the other humans on the roads. So I'm going to play it safe, because there's people who aren't like me, who didn't grow up where there's snow. And I'm going to respect their need to get to work and the need to keep the roads as empty as possible so that they can white knuckle it to their jobs or wherever they need to get with fewer things to be in their way. So let's see. That's true, Henny's Reverb. If you position yourself correctly, you can see a rainbow as a whole circle. You can do this from airplanes. It's really kind of awesome. I've seen this several different times, where actually in some cases you can even get the airplane acting as a point that the light refracts around, and you get followed around by these really cool interference patterns on the clouds. So let's see what else. Yes, Paranor, the universe is going that way. No, not Krispy Kreme. I grew up on Dunkin' Donuts. I respect Tim Hortons. When in Canada, I do eat the Tim Hortons. So Noel is saying, on a three-dimensional toroid, you can define the orientation. Can the orientation of the four-dimensional hypertoroid also be determined? So the question becomes, relative to what? And from what little of it we can see, we can't define it from our position. Okay, so let's see. I'm seeing lots of donut discussion. So Stegan is asking, have the government shutdown affected your job at all? My response to that is, I hate everything in pants. To expand upon that, CosmoQuest itself was funded previously, past tense, from 2012 up until midnight, December 31st, off of NASA grants, mission contracts, and donations from people like you when we needed them due to government cutbacks. Back in August, we heard that due to James Webb Space Telescope cost overruns, due to policy changes, there was a chance we might see funding cuts. And while that was going on, I was also in the process of looking for a position at an institution that had a whole myriad of other scientists with whom I could work. And I got that job at the Planetary Science Institute, where I'm now a senior scientist. And there are over 100 other PhD researchers working to explore our solar system and beyond. Now, the problem is, I put in my resignation letter on a Tuesday. My new institution was going to talk to NASA about transferring our grant on Friday, and transferring grants is a perfectly normal process. They have information on how to do it on the NASA FAQs, no big deal. But the Thursday before that conversation could occur, after business hours, NASA canceled our CosmoQuest grant. And we went from having 1.4 million a year to having whatever we can raise through Twitch, because we aren't allowed to ask for donations on the CosmoQuest website, well funded by NASA. So thanks to people like you, we raised $36,000. And that funding was intended to last until we could find new federal funds. The intention was, starting January 1, I would be writing new grants at my new institution, talking to folks at the National Science Foundation, at the Department of Energy, at the DoD, wherever there are people who may be interested in other worlds and machine learning and citizen science. But because of the government shutdown, I can't put in new proposals. I can't talk to program officers. And what makes it harder is those calls for grants that are currently out there, all of their due dates have been listed as to be determined. Now, I do have one NASA grant that is not related to CosmoQuest. And normally I would be in the process of transferring it. And it's enough money to pay half my salary for this year. And as I've said many times, I'm not taking any of the donations that you make for my salary. That's to pay the other people in our team, people who don't have husbands who can keep a roof over their heads. Government is shut down. I can't transfer that grant. I can't transfer it until the government comes back up. So I will not be paid, except as an artist. I sell art on my personal Twitch stream until the shutdown is over. So yeah, it's affecting me. But like I said, I have a husband who can pay our mortgage. He's kind of grouchy that I have no income, because he was like, hey, can I? And I'm like, no. But there are people out there, for instance, who work at Goddard Space Center in Baltimore, working on spacecraft. And their kids attend preschool on site. Their kids attend daycare on site. And if you have a husband and wife who both work at Goddard and their kids go to school at Goddard, their kids aren't in school and haven't been in school for 2 weeks. They have no income. What does that family do? This is affecting entire families. I have Twitch. I can ask for your help, and I hope that you give when you can. I hope that this content is something that you're willing to put bits and subscriptions into to keep it coming day after day, because we're going to be here as long as we can. You are our safety net, but other people don't have that. So if you have people in your life who are employed by the government, make sure they're okay. Take them some food if you can. Offer them whatever you can to help, because a lot of these folks don't have a safety net, especially those that are working. And I know a lot of people hate TSA, but TSA workers are some of the worst paid in the government, and they are required to go to work. Required. Same with the FAA flight controllers. They're required to go to work, and they're not getting paid. Take care of those people, because they're the ones that are taking care of us. And it's a bad world out there right now. It's part of why I'm so glad that I do get to come on here and celebrate science with all of you. Talk about the discoveries. Today I talked about science coming out of Japan, because there isn't science coming out of Hubble right now. It's where it is. Okay. Yeah. Yes, exoplanet formation is a roller derby. I agree with that. Scrolling to see what else is there. So Noel Hexacoron is saying, on the surface of a sphere, you can travel in any direction and return to the point you started. On a torus, there are 2 axes you can travel on that will take you. Thank you so much, Veronica Cure, for the bits. Thank you. That will take you to the place you started most quickly. If the universe is toroidal, I expect it would have universally definable set of axes. Yes. Now the problem is we haven't seen light come back to us. If we did, we could look out on the cosmic microwave background in 2 different directions and see patches of light that were identical patterns. And because we don't see those 2 identical patterns that would totally define the orientation for us, we can't define the orientation. And this tells us the minimum size of the universe that we're able to see. So Astro B. London is saying, we are told the universe is presently 46 light years in every direction. How far? So that's the observable universe, the part of the universe we can see. And it depends on whose constants you use. But yeah, it's tens of billions of light years in every direction. How far are we from the middle of that calculated universe's edge? So that number that you're talking about is strictly the size of what we're able to see, because the light has had time to reach us since the first moments of the universe. Now, the universe itself, it's estimated based on the fact that we can't see those 2 identical patterns of light. So that tells us that over the time that the universe has had to exist, light was not emitted and traveled and traveled and traveled to reach us around the universe. And so the universe must be at least this much bigger than what we can see. Now, since what we see is limited to how long has light been traveling, it's actually a sphere that we're in the center of. But as we move, the sphere moves with us. So you can't ever get to the edge, because you always have this sphere of light around you that is the observable universe. The analogy that I like to use is swimming underwater at night with a headlamp. There's a sphere around you that you're able to see, but unless you're near an edge, you have no idea how big that body of water is. You only know that it's bigger than the sphere of light that your lamp allows you to see. Yeah, Bill Nash, the shutdown impacts aren't linear. It's a steep curve with growing impacts. It's really bad. So there was a great trickle down discussion yesterday. I think it was on the New York Times, the Daily. I think it was either there or NPR, where they talked about how, so you shut down a government building. That 800,000 number that they keep toting as 800,000 government workers aren't getting a paycheck, 800,000 government workers are furloughed or required to report to work unpaid. So when you shut down a building that those people would work in, there's also going to be a large number of contractors. This is particularly true for the NASA centers where you have civil servants, but the bulk of the work is done by contractors. If you shut down the center, those contractors that aren't allowed to report to work aren't allowed to bill hours. They aren't getting that money back. The furloughed workers, they'll get their back salary eventually. The contractors just have a gap in pay that is never coming back. So those are the people who are building the spacecrafts, who are doing the day-to-day IT work, who are doing all this other stuff. Now, in addition to those contractors that are doing work directly for the government, you also have all the support. So you have that food truck, you have that catering service, you have all those day-to-day blue-collar workers. Thank you, Stegan. Thank you. So it's a huge trickle-down effect. I'm really worried about what's going to happen to the U.S. economy. This is the equivalent of, just for the 800,000, an increase of 0.5 percentage point in unemployment, and they are only a fraction of a majority fraction, I hope, of the people not getting paid. That's a huge increase. Okay. Yeah, thank you, Bill. And I can do this. So Bill is another streamer who does a lot of photography, and it's just stunningly beautiful. I love to just sit and watch his channel because it's pretty. And I learn things, but mostly it's pretty. Yeah. Yeah, stringtory, it's detrimental. So yes, Larry, weird and proud. Hubble is still broke, and it looks like they may not be able to fix it until the government shutdown is over. I don't know the details of what's wrong. It's only one of the instruments. The wide field camera 3 is not working. I don't know the details. I'm not sure they've been able to communicate the details because the communications office not fully there either. Yeah. Scrolling up to see what Tellurian H2O said. Oh, I'm not seeing it. Sorry, I need to move the chat closer to my face. I'm totally not finding. There it is. So Tellurian wrote, maybe you do not want to go down this rabbit hole, but I do know people who make good money just writing grant proposals for others. So I actually have been one of those people. I've been hired to write grants for people. I actually wrote all of the original grants for founding the Zooniverse here in the United States before we split off to form CosmoQuest. Yeah. And I've been hired by other people to write grants. The writing of the grants isn't a problem. It's the having someone to give me the money that's the issue right now. If you need narrators, we'll narrate for science dollars. Yeah, the national parks are being vandalized. Joshua Tree. I do all the things because I have to do all the things. Well, I narrate because I love it. Everyone needs a passion, and for me, that's something I'm passionate about doing. Yeah. Anyways, this is becoming an extremely depressing daily space. Extremely depressing because the world is not pretty right now, but the universe is. Come join us for Astronomy Cast at 3 p.m. Eastern over on YouTube. That is noon Eastern, 8 p.m. London. And we're going to talk about how heavy elements are made in stars, how stars shine, how that light supports them against the crush of gravity, as we all need to try and find light to support us against the gravity of this world that we all live in. It's a world that we make, though. So as Bill pointed out, call your Congress critters if you're in the United States, and check on your neighbors. See if they're government workers. See if they need help. People are often too proud to admit when they need help. So if you see a need, don't ask if they want something. Just tromp on over and say, hey, I made too much chili in my crock pot. Have chili. Help your neighbors. Be good to one another. That's how we change the world. So you all have been wonderful. There will be random ninja streams, I suspect, as I continue to work on CosmoQuest.org. And I think that's all I've got for today. We will return for certain on Monday at 1 p.m. Eastern, 10 a.m. Pacific, 6 p.m. London, to bring you all that is new in astronomy and space science. As a reminder, next weekend, not tomorrow, but a week from tomorrow, I will be in Boston attending the Aresia Science Fiction Science Fantasy Convention, where I will be bringing the science, and I will be part of the Broad Universe table. So if you're local, come say hello. And if you're not, I wish you could be there, and I'll eat a donut for you, whether I should or not. So thanks for being here, and wherever you are in the world, have a fabulous morning, evening, afternoon. Go, remember to look up, and I will try and find someone to raid once the credits are done rolling. So don't go away. Instead, be ready for more science to happen. Bye-bye.